Earlier this month, I attempted to compare DeepSeek's large language models with OpenAI's by using both of them to convert some unstructured data into structured data using Python. But I wasn't able to finish my test because DeepSeek's API went down after my first run. Now, DeepSeek's API is back up, so I finished my tests. And in this video, after I provide you with some context, I'm going to walk through the program I designed to compare the models from DeepSeek and the models from OpenAI. And then I'll give you the results. And finally, I'll show you how to access the GitHub repository associated with this project so that you can dig in and play with the code yourself. For context, PyFi teaches finance professionals how to code in Python. And in support of our marketing efforts, I've been surveying job postings that target finance professionals who can code in Python in order to understand why companies hire people with this skill set. Part of my analysis requires me to convert unstructured data into structured data. And since large language models are well suited for this kind of conversion, I decided to use the analysis as an opportunity to apply OpenAI's API in a Python program for the first time. As I was finishing my program, DeepSeek's R1 model was announced, and so I decided to create an alternate version of the program using DeepSeek's models instead of OpenAI's so that I could compare the performance of the two. So this is what my job posting data looks like. I have one job posting in each row of this table, and I'm documenting the company type, the job title, the job location, whether or not Python satisfies a requirement or merely a preference, and whether or not Python is listed exclusively as a requirement or a preference, or whether it's listed among alternatives. For example, some job postings will say the successful candidate should have experience in Python or R or SQL, maybe. So if Python's listed among alternatives, I had my research assistant list those alternatives in this table called alternatives. The problem is that I can't statistically analyze the data in this alternatives column because it's unstructured. So somehow I needed to convert this unstructured data into structured data, like an indicator column, like you see here, that is flagged whenever a certain tool is mentioned. Here's how the program works. First, I install the OpenAI package so I can import it, and I import the other packages that I need. So I have Pandas, Pydantic, and OpenAI. Then I read my job posting data into my program. So now I have the same data we were looking at earlier in a data frame instead of a CSV file. Then I create an OpenAI type client object right here using this OpenAI type constructor with an API key. By the time you watch this video, this API key will be disabled, but if you log into the GitHub, you'll be able to replace this with your own API key. After that, I define a function that I can use to prompt models through the API so that I don't have to retype all of this code every time I want to submit a prompt. And then we use that function to extract a list of unique tools. To reduce the model's error, I've divided this task into 3 separate prompts. The first one tells the model to extract a list of unique tools without any constraints around naming or organization. The second prompt asks the model to rename the tools in the response to the first prompt so that they can be used as Python variables. And then the third prompt tells the model to organize the tools in the response to the second prompt in a Python list according to Python syntax. So first, I isolate that alternatives column that we saw in our data set, and I convert its data into a string so that it can be read more easily by the model. Then in my first prompt, I tell the model to extract a list of unique tools from that string. And I'm sending this prompt to the O1 preview model, which takes more time to compute its response. In this case, it took 26 seconds. And the response it gave me includes a little preface and then a list of tools that look like the right idea. However, some of these tools don't conform to Python syntax for variables. For example, .NET would not be a valid Python variable because it begins with the dot symbol. So I need to convert that. In my second prompt, I tell O1 preview again to rename the tools according to Python variable syntax. If I scroll to the end of this response, I see that .NET with the dot symbol has been converted to .NET spelled out. Finally, in my third prompt, I tell the model to organize the tools into a Python list, and I do this using GPT-4o And the reason why I do that is because this model supports structured outputs, meaning I can pass the model a JSON schema, and the model's response will conform to that schema. This ensures that I can use the output of the model in my Python program. Because I'm using the GPT-4o model, I get a response to this prompt in 2 seconds instead of 23. And I see that I do get a Python list containing tool names. Before I move on, I want to make a few changes. I see that Amazon QuickSight and Amazon Web Services, AWS, both contain the word Amazon, and I want to help the model to avoid confusing one of these tools for the other. So I'm going to remove Amazon and change these tool names to just QuickSight and AWS. And then I see that C++ has been converted to CPP, which is not completely clear. So I'll change this name to be more explicit, like C#. So here I've defined the changes that I want to make to the names of the tools in that list. When I execute this cell, I get a new list and I see that C++ is updated, AWS is updated, and Amazon QuickSight has been changed to just QuickSight. So since I'm happy with these tool names, I can use this list to create a set of indicator columns in my data frame. And by default, I'm setting the values of all of the rows in all of these indicator columns to false, and we'll update those values in the next step. After I execute this cell, I can see that I have created these new columns. Now we're going to use the OpenAI model to flag our indicator columns. First, I'm initializing a dictionary that I'll use to store unexpected tools that the model identifies. Then I define a JSON schema to constrain the model's output like I did in the earlier prompt. And then I create a for loop to loop through each row of my alternatives column, update the indicator columns based on the tools that the model identifies in each row, and then record any unexpected tools that it finds in this unexpected tools dictionary. This loop sends a different prompt to GPT-4o for every one of the 100 rows in my alternatives column. So executing this cell takes a little bit longer. As I execute, I can see that the model is going through the rows, identifying expected tools and also unexpected tools like SQB and other BI packages. After 1 minute and 4 seconds, I've finished looping through all of the rows in my alternatives column. So I can evaluate the results. If I execute this cell, I can see the unexpected tools that the model identified. Here I see that we missed Oracle up in our first prompt right here. We asked O1 Preview to give us a list of unique tools that were mentioned in that column. But down here, I see that Oracle was not in that list. And if I scroll over, I see that the model is listing Amazon QuickSight and Amazon Web Services as unexpected tools, which it shouldn't. And it's also identifying a tool that was missed in the response to the first prompt, Databricks. In order to analyze the output of the model in greater detail, I can export this data frame to a CSV, and then I designed a tool to score the CSV. I'll show you the results in just a second. The DeepSeek version of this program is almost identical. I go through the same steps. I import a slightly different set of packages. I define a slightly different function. I give the model almost identical prompts. I make some changes because the DeepSeek models require different kinds of prompts in order to output JSON objects. So I make some modifications for that. But in this program, I go through almost exactly the same process. So how do DeepSeek's models compare to OpenAI's? In the first prompt, where we were asking the model to extract unique tools, OpenAI's model, GPT-01, took 38 seconds on average, whereas DeepSeek's model, R1, took 92 seconds on average, more than twice as long. However, GPT-01 cost an average of 25 cents per prompt, whereas DeepSeek cost less than 1 cent per query. Both models averaged 2 omissions. For some reason, they both missed Oracle and Databricks consistently. And both models included one tool that wasn't actually in the alternatives column in one instance. With the second prompt, where we asked the models to rename the tools to serve as Python variables, again, OpenAI's model took less than half the time of DeepSeek's model, although DeepSeek's model was significantly less expensive. Both OpenAI's model and DeepSeek's model were error-free in all 5 tests. In prompt 3, where we asked the models to organize our tools into a Python list, OpenAI was 4 times quicker. Both were inexpensive. And it's worth noting that here we're now using OpenAI's GPT-4o model and DeepSeek's V3 model instead of the GPT-o1 and R1 models. Then finally, in the 4th prompt, where we're actually sending 100 prompts to each model using GPT-4o and V3, OpenAI's model took 1.5 minutes, 89 seconds, and DeepSeek's model took 481 seconds, or 8 minutes on average. Again, DeepSeek's model is significantly less expensive than OpenAI's, and the errors were almost identical. Both did well. In summary, I'd say that DeepSeek's models are indistinguishable from OpenAI's models in terms of error. Both companies' models committed the same number of errors on average in each prompt. OpenAI's models are significantly faster than DeepSeek's, but DeepSeek's are significantly cheaper than OpenAI's. Finally, OpenAI does seem to be more reliable. When I was trying to test DeepSeek's models last time, their website and their API went down for several days. If you want to dig into the code for yourself, you can click on the link in the description below this video, and that'll take you to PyFi's repository associated with this project. There you'll find 2 Jupyter notebooks, job posting analysis OpenAI, and the DeepSeek version, as well as the job data that we're analyzing, which you're free to dig into separately if you want to. Thanks for joining me in this comparison between DeepSeek and OpenAI. If you liked the video, give it a like. If you have a question, drop it in the comments. And if you want to see more, subscribe, and I'll see you in the next one.